Hello, and welcome to your first video lesson in geometry. I'm going to ask that you take notes. It's going to be a major portion of your grade, so please write down the things that come up, and I'll explain what you want to write and what you do not want to write. But one important thing is this year, I want to make sure that you title your notes. So this right here is the title of the lesson. It says 1.1 Points, Lines, and Planes. Please make sure at the top of your notes, whenever we start a new section, that you always have the title. And I also would like for you to have the date. So I'll show you maybe a sample of what it should look like. If this is your note page, you should have the title, which in this one is 1.1, Points, Lines, and Planes. And I like for you to underline it or highlight it in some way. That way you can easily find it when you need to. And please put the date, whichever day that you're taking those notes, so you keep track of it. And then you'll go ahead and write all your notes that I tell you to write. Notice I'm using green ink. Green means go. When I have green on the board, I'd like for you to make sure you get it in your notebook. If I use red, this means sometimes I like to draw things and show you what not to do and show you some other situations. So you don't want to draw what's in red. So please write down in your notes what's in green and not what's in red. And I will clarify each slide too to help you out. So let's get right to it. So please make sure your title is ready and please put the date. And this picture here that you're seeing, this picture, you do not have to write this in your notes. These are simply placeholders for me to introduce the lesson sometimes, just so you don't have to look at a white screen. So you do not have to draw this picture here, just simply the title and date. Let's get going. So the very first thing in your notes, this is a big chart. I'm going to let you take the whole day to copy this one. Please make it look just like this. So pause the video, take some time, and write this entire chart. And that'll actually be an entire lesson of itself. So once you're finished with the chart, you'll be done for the day. We do have more notes in this section. However, I don't like to overload you with notes on any given day, especially in the virtual environment. So please copy this chart exactly as you see it in your notes. Very nice with columns and some rows. Make sure you draw the pictures. I also want to do your best to make these lines straight and these pictures nice and neat so you can read them. But this is a very important chart. I don't really have you copy charts too often, but when I do, they're very important. So please take note of all the things that the chart says about what a point. It has no size. It basically indicates a location. Lines are straight. They have no thickness, and they extend indefinitely, which means basically they go on forever. Pretty easy stuff. A segment is simply a piece of a line or part of a line. It has two endpoints, so we actually have a definitive length of a segment. So lines, they go forever. Segments are just a piece of a line. They stop. Then we have a thing called a ray, which is part of a line. So it has an endpoint, and it kind of goes forever in a direction. And you could think of something like a sunshine ray, like it starts at the sun and it kind of extends out forever, or like a laser pointer. That's a good way to think about it. And then a plane. A plane is simply a flat surface, kind of like a piece of paper, a chalkboard. But in geometry, it doesn't have thickness. So those things like a piece of paper, or a tabletop, or chalkboard, they help us understand what a plane is, and we draw them like that too. We actually draw them to where they are flat surfaces, but they actually do not have thickness, and they do also extend just like a line indefinitely in all directions. So it's going to extend out that way and that way. It does not stop. So like a line, a plane does not stop. A segment stops in both directions. A ray only stops in one. So I'd like for you to take here some time and get through these properties and these drawings. The symbols are very important this year too, and how you read them. So we'll be using these quite a bit this year. All right, now these are notes that you're going to copy, but this would be day 2 technically for your notes. So I've typed these and I already have the pictures. I'll talk about them. I want to make sure you get these in your notebook. So you can pause the screen if you need more time. And please write down exactly what you see. It's very simple to get a very good grade just by copying these simple notes down. So we're going to talk about collinear points. And collinear, just like it sounds, they share a line. So collinear makes sense. So basically it's points. We've got 3 points here, A, B, and C, that are on the same line. So if you can draw one line through the points, they are said to be collinear. And if I put another point here, this will be an interesting thing. Let's see if I put a point, we'll do D, I guess. We'll stick with the A, B, C, D. If I ask you if points C and D, so point C and point D are collinear, your answer is actually yes. Now, the reason it's yes, and I'm going to draw in red, which means you don't have to copy this stuff. I could draw a line right through those two, and that makes them collinear. So any 2 points, you can always draw a line through, even if you don't see the line. So I'm going to get rid of some of my markings here. Put our points back here. And let's move on to coplanar. It has a lot of the same ideas. We've got some points on a flat surface or a plane. It's quite easy. Basically, if the points are all on the same flat surface, or if you could make a flat surface through the points, it's coplanar. So let's take a look. A, B, C, D, and E, they're all coplanar. And let's throw another point here. I don't know, we'll do F, I guess. And if we put F there, would F be coplanar with those other points? The answer is yes. Well, what would be something that's non-coplanar or non-collinear? Let's take a look at those. And remember, pause the video if you have any trouble understanding of any specific topic. That's one of the best things about watching the videos. You can stop as you please and take a look and look further into a topic. So let's take a look at what non-coplanar, non-collinear. So all of these points are definitely not in a straight line. So that's a pretty easy one. These are called non-coplanar. However, I'm going to go to red, so you do not have to write this. This is me. I like to play around a lot on these slides. If I was to draw a line maybe through these 2 points, those are collinear. But as soon as if I add this third point here, they would be non-collinear. So let me put some letters on them to make some sense. So this would be A, B, and then we'll do C here. So if I say are points A and B collinear, your answer is yes. If I say are points A, B, C collinear, that's where your answer is no. As you can see, you clearly cannot make a straight line there. So you're always looking for that straight line. And remember, anytime you have 2 points, no matter where they are, even if you don't see the line, they have to be collinear. And coplanar, and now this is definitely a tricky section. So I'm going to try to go very slow and help you out here. Non-coplanar, so they're not on the same plane. So let's find some points. So examples are really going to help here. So let's think of some points that are not the same plane. Well, if I take the points L, M, O, and then I take the point A. These, as you can see, L, M, O, they were on the same plane, but A was on a different plane. So you can't call those coplanar. They're on different planes. Let's find another example of a non-coplanar. How about points N, M, C, and B? I'll write those down because we want to have examples. M, N, C, and B. Those are non-coplanar because you can see you could never put a flat surface through all 4 of these points. And that's what you're really looking for, to put a flat surface through them. Let's try a tricky one now. This is where it gets very tricky, and if you don't understand this right away, it's okay. It's very normal. Every year students struggle with this idea, but I'll do my best. If I just say 3 points, so let me just pick any 3. We'll do M, A, and then P. So if I took those 3 points and I say, are they coplanar? You would look at the figure and you'd say, well, they're not in the same plane, so no. But that's where the tricky thing is. Could you put a flat surface through those 3 points? And the answer is yes. So believe it or not, M, A, P, coplanar. It's a lot like if I go back up top here. If I ask you if AC or AB was collinear, you didn't see that line, but the answer was yes, because remember, any 2 points, it's collinear. Well, it's the same idea. Any 3 points, it has to be coplanar. So that's where it's very tricky. It's a rule where any 3 points have to be coplanar. There's only one exception to that rule, and that's if they're all in the same line. And that's a tricky answer we're not going to get into right now. But any 3 points, as long as they're not in a straight line, have to be coplanar. So when you're looking for non-coplanar, let's get back to this idea, because you may have to rewatch this part again a few times to understand. When we get to non-coplanar, we need to look for 4 points. So when you're looking for non-coplanar, make sure, I'm going to put this one in green actually, because I want this in your notes. 4 points. Because remember, if you pick 3 points, even though you don't see the plane, you could always make a plane through any 3 points, as long as they're not in a straight line. And now we're going to move on to something called postulates. And this is pretty interesting. And this leads right to, this actually is right from what we just talked about. So hopefully it makes some sense going right afterwards. But first we have to talk about what is a postulate. Well, postulate is simply, we'll just call it a geometry rule for this course. So it's simply a rule in geometry, and we have to take it and accept it for what it is. It's a rule. So let's take a look at what it says. 2 points determine exactly one line, and that makes perfect sense. I'm going to go backwards then, because remember, if I picked any of these 2 points, just pick 2 of them, any 2, you can make exactly one line through those 2 points. So we use the word determine. I like to think of the word create. Any 2 points create a line. So if I take a look here, there's my 2 points, and there's my line I created. And that's exactly one line. There is no other line that could go through those 2 points. It's exactly one. And in the same idea, and this is where hopefully if you didn't understand this section, this non-coplanar, which is very normal, hopefully this helps a little bit more. You got to have 4 points to be not in the same plane, because if you have 3 non-collinear, so 3 points that are not in the same line, which I have right here, let's label these A, B, and C, then they determine exactly one plane. So once again, we a lot of the same words, determine and determine, exactly, one, and instead of line, it's plane. So 3 points, and I'm going to kind of make like a little illustration here. 3 points make a plane. And I know they're all on my board, but believe it or not, you can play with this idea. If you make, your 2 fists, each one a point, and then your foot be the 3rd point, you can move your 2 fists around and your foot and try to make a way that you can't put a flat surface across those 3 points. But guess what? You won't be able to do it. I've tried, trust me. So let's recap here. A lot of new ideas, some things you probably never heard of. I want to go back through some of these things. So our big things today are, collinear and coplanar. So I'm going to go back one more time. Remember, collinear means the points are on the same line. Coplanar means the points are on the same plane. Well, how do we get non-collinear? Well, that's easy. Non-collinear would be where I have 3 points. Get rid of these. Any 3 points, for example, A, B, and C now. If I made those 3 points, those are definitely non-collinear. But if I just pick 2 points, remember, they have to be collinear. And just like the non-collinear, the non-coplanar, if you pick 4 points and you see there's 2 different flat surfaces there, if you pick 4 points, 2 points on, we'll actually color code these. I'm going to go to some new colors. I'll call this purple. I know this idea is tough, so I want to just make sure we go through it one more time. And then we'll do maybe blue. So I've got a purple plane and a blue plane. So if I pick 2 points from the purple and 2 from the blue, I'm definitely non-coplanar. But be careful, because if you pick 3 points, you will have to be coplanar even though you don't see the plane. It's really just asking, could you make a plane if you have 3 points? The answer is we can always do that. And the reason we know this is right here. Any 2 points you always make a line. So any 2 points, we'll call this point A and point B. And any 3 points, we can always make a plane. So that means any 3 points, as long as they're not in a straight line, we have to be coplanar. So there's probably a lot of new terminology in your head. Just go back and make sure that you copied this chart very well, because it helps you understand what some of these terms mean. So that concludes our first section of virtual notes. You'll see the homework listed online underneath the assignment.